Hello, students. Welcome to the sixth semester class. As you know, I will be teaching to you in this sixth semester the paper of optical fiber and communication. The course code of the paper is PHY 612. Total periods are 45 and it is carrying the credit of 2 marks. Maximum mark is 50, out of which 40 marks will be the university theory paper and 10 marks there will be internal examination that we call as a continuous internal assessment. So the outcome of the course is, on successful completion of the course, students will be able to first realize the significance of optical fiber communication. So, as you know, in today's world, optical fiber communication is very widely used for communication purpose, in which we use optical fibers. So, optical fibers. So, in this course, we will be discussing about the optical fibers, its construction, the physical phenomena involved in the optical fiber communication, then how the optical fiber system or optical system is designed, then we can understand the construction and working of the optical fiber cable. Also, we will have some knowledge about fabrication of optical fibers, and lastly we will identify and understand the need of optical fiber communication. So to start with, here we are discussing the unit 1, introduction to fiber optics. So in this unit we are going to discuss introduction, construction of optical fiber cable, working of optical fiber, strength members, types of optical fiber, uh, step index fiber, graded index fiber, plastic optical fiber, glass fiber, importance of optical fiber, advantages of and disadvantages of optical fiber in the communication. So this is all about the first topic or first unit. So let us start or let us discuss the topic one by one. So as I told you, in this first unit, we are going to discuss about the optical fiber technology, the basics of optical fiber cable and optical fibers. So fiber optics is a technology that uses light to transmit data through thin strands of glass or plastic known as optical fibers. This method of communication has revolutionized data transmission due to its high speed, efficiency, and minimal signal loss. So, as seen here, optical fiber communication, the optical fibers are made from plastic or glass. Basically, two types of materials are used to usually in manufacturing the optical fibers. Uh, it can be glass or it can be plastic, depending upon the uh, applications where we want to use that optical fiber. Then what are the advantages or what are the main characteristics of the optical fiber communication? So as we see here, the main characteristics are its high speed. It can transmit data of gigabytes with a high speed. In microsecond or millisecond, the huge amount of data can be transferred from one place to another place with the help of optical fibers. So it is having very high speed. Then secondly, its efficiency is very high. So all these advantages are uh, with reference to the conventional communication systems, that is cable communication. So one thing is it is having high speed. Secondly, its efficiency is also very high. Third thing is that it has minimal signal losses. So we know that in conventional communication system, there are the loss of the signal is the major concern. So which has been minimized to large extent in case of optical fibers. No loss at all. So the another point or the next point is construction of optical fiber cable. An optical fiber cable consists of several layers. So as we see here, here is the fiber optical construction. We can see the picture of an optical fiber. How does it consist of? So as we see from the figure, it is having mainly jacket, then buffer, then cladding, and then core. So let us see one by one. Here the core. The first or main part of the optical fiber is core. So core is the central part where light travels. Light travels means the signal which we want to communicate, which we want to transmit from one point to another point across the globe, that can travel through the central part which is called as core. The signal is traveled from one point to another point by means of a light or through light, we can see. Typically, the core is made up of glass or plastic. Then the core is surrounded by what we call as a cladding. The cladding, it is a layer surrounding to the core with a lower refractive index to ensure total internal reflection of light within the core. What does it mean? Through the light, through the core, the light travels, and core is surrounded by what we call as a cladding. So what is the function of cladding? Cladding limits the light within the core itself, because we know that when light travels from medium through medium, there is a possibility of getting out the light reflected, or light can be reflected, or light can be transmitted from one medium to another medium. So when the core is made up of glass or plastic, you can say, there is a possibility that light may get refracted through the core. It can leave the core and get transmitted to another medium. So to avoid this, there is a surrounding which we call as a cladding, and the refractive index of the cladding is lower than that of the core. So because of which, what happens, the entire arrangement, we can say, the entire structure of the cable is such that the whatever light is traveling through the core, the light keeps on traveling through the core by means of phenomena which we call as a total internal reflection. Then there is a buffer coating. The On the outer side of the cladding, there is a coating which we call as a buffer coating. So what does it do? It is the protective layer to safeguard against mechanical damage or environmental factors. So core and cladding constitute the main part of the optical fiber, but as it is very delicate, it is made up of glass or plastic, as we have said. It has to be protected from the environmental factors. So to safeguard it, it is coated with what we call as a buffer. And again, after that buffer, there is a jacket, the outer protective sheath that provides durability and flexibility to the cable. So this is about how the optical fiber uh, is made, or the construction of the optical fiber. the structure of the optical fiber. Now, let us have some idea about working of optical fiber. Light signals are transmitted through core of the optical fiber by principle of total internal reflection TIR. The cladding ensures that the light remains confined within the core by reflecting it back when it attempts to escape. The signal travels long distance within the minimal attenuation. Attenuation means loss of signal, making fiber optics ideal for communication network. So here this diagram clearly shows how the light is traveling from sender point to receiver point through core by means of total internal reflection. The central part is what we call as a dense core. That means refractive index of the core material is higher than that of the cladding material. So light transmission through optical fiber. The next point is strength member. Strength members are added components in optical fiber cables that enhance durability and prevent damage due to bending, pulling, or environmental factors. And, what is strength member? It is again added strength, or we can say enhanced durability to prevent. It can prevent the damage due to bending, pulling, or environmental factors. This may include a kelvar that provides tensile strength on the cable. Steel wire reinforcement. It is used in some cable for added mechanical protection. What is done actually when the optical fiber cable is manufactured along with the core cladding and buffer material or buffer, and added steel wire is also reinforced along with the optical fiber, and this steel wire uh, adds the mechanical strength or mechanical protection to the optical cable. Then there is a central strength member, rods or filaments that support the fiber's structural integrity. Now, let us see in brief the types of optical fibers. Following table shows classification of optical fibers on different bases such as material, mode of transmission, and refractive index profile. So, as we see here, the optical fiber can be classified on different basis. For example, it can be classified on the basis of material used, just we can say plastic optical fiber or glass optical fiber. Also, it can be classified on the basis of mode of transmission and refractive index profile. So basically, the material used. So on the basis of material used, there are two types of fiber: glass fiber and plastic fiber. Then on the basis of mode of transmission, there can be again two types of optical fibers. One is single mode and another is multi mode. So we are going to discuss this one by one in detail in the next lectures. Just for time being, just you have a note of single mode and multi mode. And then on the basis of refractive index profile, again there are two types of optical fibers: step index fiber and graded index fiber. So following figure shows the types of optical fiber based on mode of transmission, such as single mode or mono mode and multi-mode optical fiber. It also shows the step index and graded index optical fiber. So we will discuss this in the next lecture. For the time being, just you have a revision of the topic taught today at your home. Uh, Okay, we will meet in the next class. Thank you.